prepare for a potential cosmic catastrophe of unimaginable magnitude. Betelgeuse, the massive red giant star situated on the edge of our galaxy, is sending disturbing signals across the universe. Using the advanced technology of the James Webb Space Telescope, astronomers have uncovered a chilling mystery surrounding this vast celestial entity. With renowned astrophysicist Brian Cox issuing a grave warning, the question now looms: are we on the brink of witnessing a catastrophic supernova explosion that could forever alter the night sky, changing the way we see the cosmos? Let's explore this phenomenon further. In the vast and ever-expanding cosmos, where stars are born, evolve, and ultimately meet their fiery demise, one star has recently captured the attention and concern of both scientists and the general public. This star is none other than Betelgeuse, a red supergiant of incredible size and age, located in the prominent constellation Orion. Known for its striking reddish hue and fluctuating brightness, Betelgeuse has long intrigued astronomers, but recent developments have heightened interest in this colossal star. As we delve deeper into the nature of Betelgeuse, we find ourselves potentially standing on the precipice of a monumental event in the star's life. But what do these recent changes mean? Could this be the beginning of a cosmic spectacle of unprecedented scale? Betelgeuse, with a size that is roughly 764 times that of our Sun, is a stellar behemoth. The sheer magnitude of its size is almost beyond human comprehension. To put it into perspective, if Betelgeuse were to replace our Sun, its surface would stretch beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and Mars in its immense stellar embrace. This vast size doesn't just reflect the star's impressive physical characteristics, it also speaks to the current phase of its life cycle. As a red supergiant, Betelgeuse is nearing the end of its life, a stage marked by expansion and cooling after millions of years of fusing hydrogen into helium in its core. But what about Betelgeuse's age? At approximately 8 to 8.5 million years old, this star is relatively young in terms of human lifetimes, but ancient when viewed through the lens of stellar evolution. The current phase of Betelgeuse, as a red supergiant, is the final chapter in a long process of stellar evolution. Over millions of years, it has transformed from a hot, blue star into the red giant we observe today. The life cycle of stars like Betelgeuse is a narrative of profound transformation, driven by the relentless forces of nuclear fusion and gravity. Betelgeuse's reddish hue is one of the defining features of its current state. The color comes from the star's relatively cooler surface temperature compared to other stars like our Sun. While the Sun's surface temperature is approximately 5,500 Kelvin, Betelgeuse's surface temperature is a much cooler 3,500 Kelvin. This lower temperature allows Betelgeuse to emit light at longer wavelengths, giving it its characteristic red color. But this color is not just for show. It provides critical insights into the star's physical condition and the processes occurring deep within its massive gaseous envelope. Adding to Betelgeuse's mystery is the historical shift in its color. Ancient records from Roman and Chinese civilizations suggest that around 2,000 years ago, Betelgeuse was a yellow star. It was only in the 9th century that Arabic scholars began to describe the star as red. This change in color over the centuries is more than a curious footnote in the history of astronomy. It offers valuable clues about Betelgeuse's evolutionary path. Another fascinating aspect of Betelgeuse is its variable brightness. It is a semi-regular variable star, which means its brightness fluctuates in a periodic fashion. This variability has been a source of fascination for astronomers and amateur stargazers alike for centuries. Betelgeuse typically follows a 400-day cycle, with an even longer, 5-year cycle in its luminosity. These cycles have been recorded since 1836 by astronomer Sir John Herschel and were even referenced in Aboriginal oral traditions, suggesting that the variability of Betelgeuse has been noticed for centuries. However, what truly sets Betelgeuse apart is not just its changing brightness, but its irregular behavior. Unlike many stars that follow predictable brightness patterns, Betelgeuse occasionally deviates from its normal cycles, offering a glimpse into the complex and poorly understood processes happening inside the star. This irregularity raises more questions than answers, highlighting the unique and mysterious nature of this massive stellar body. In late 2019, Betelgeuse shocked astronomers and the public alike with an unexpected dimming event that captured worldwide attention. This event, now famously known as the Great Dimming, saw one of the brightest stars in the night sky suddenly lose its brilliance. Betelgeuse, a prominent feature of the Orion constellation, began to fade at a rate of about 0.01 magnitudes per day, with the star reaching its dimmest point by February 2020. This dramatic change was so pronounced that even amateur astronomers could see the difference. However, there is an inherent time paradox when studying distant stars like Betelgeuse. When we observe stars, we are not seeing them as they exist in the present moment. Due to the vast distances between us and these stars, the light we see today left the star in the past. In the case of Betelgeuse, at a distance of about 725 light-years, the light we perceive now left the star nearly 7 centuries ago. This time lag means that we are essentially peering into the history of the star, making it difficult to predict or monitor sudden changes in behavior. This dimming event served as a stark reminder of the challenges of conducting real-time astronomical observations and the limitations imposed by the vastness of space and the time scales involved. As astronomers attempted to make sense of the event, they had to account for the fact that the data they were observing represented a snapshot of Betelgeuse as it existed in the past. The Betelgeuse dimming was closely monitored by Andrea Dupree, the Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her research team. They used the Hubble Space Telescope to analyze the star as part of a multi-year study to monitor changes in its outer atmosphere. These observations provided a rare opportunity to gain insight into the dynamics of a variable star, a star that regularly expands and contracts, causing fluctuations in its brightness. By using Hubble's sensitivity to ultraviolet light, the team was able to probe the layers of Betelgeuse's atmosphere above its surface. These layers are heated by the star's turbulent convection cells, which further complicate our understanding of its behavior. Analysis of the spectra taken by Hubble at different times throughout 2019 and 2020 helped astronomers measure the movement of material within Betelgeuse's outer layers. They focused on magnesium lines, which indicate the physical conditions of the star's atmosphere. These observations revealed that material was being ejected from Betelgeuse's surface at speeds of about 200,000 miles per hour, extending millions of miles into the star's outer atmosphere. This hot, dense material eventually contributed to the dust cloud that led to the star's dimming. Dupree's team estimated that Betelgeuse lost about twice the normal amount of material from its southern hemisphere during the 3 months of this outburst. This significant mass loss prompted discussions among astronomers about the possibility that this event could be an early indicator of an impending supernova explosion. Betelgeuse's proximity, only 725 light-years from Earth, adds to the intrigue. If a star were to go supernova, the explosion would be visible from Earth, offering scientists a rare and incredible opportunity to observe such an event up close. But despite the excitement, the big question remains: what does this dimming event mean for Betelgeuse's future? Is it a precursor to a supernova explosion, or merely an unusual chapter in the star's lengthy and complex existence? Several theories have been proposed to explain the sudden change in Betelgeuse's behavior. One prevalent hypothesis suggests that this is part of the supernova explosion process, a phase that many believe Betelgeuse is approaching as it nears the end of its life. Another theory suggests that dust, possibly ejected from the star itself, could be obscuring our view. Like many red supergiants, Betelgeuse sheds material into space, and this material might have formed a dense dust cloud that is now blocking our view of the star, leading to the observed dimming.